maybe I will start while the technical things are solved. I will walk you through a very kind of a tiny story, but the language is biology. So I will have to do a little bit of biology there. And I apologize, because you cannot understand the story without going into understanding the biology behind it. And I will try to do it very simple. Okay? So I'll do with the clicker. Okay. Okay.
Not working much.
So, and I will describe a story that starts from very basic science in biology, going into using the opportunities that are emerging from this basic science into a applied kind of period of time in the laboratory and then out into the industry, and then how it took us back to very deep basic science. Nothing is moving here. Not even the clicking. Now it's working?
Yes, you need to have an
Okay.
experience.
So,
Apply
always often is saving, the situations. So I'll start with very basic story. It's a basic in population biology, and I'm going to talk about crustaceans, prawns. As you can see, the whole story will be prawns. I know nothing other than crustaceans. Okay. So when we are looking at a population of prawns of the same age, okay, of the same age, same hatching batch, like same mother even, we could see that the size distribution is changing in a way that the females are uniform, here about 38, 40 grams, okay? The males have several types. One is those small males that you see here, okay? Same age, same hatching batch, okay? Others are, like this one, are medium sizes, they are growing fast, and there is a peak of very large ones like this that are the dominant males. The dominant males that are governing the population. And those dominant males are the largest, the territorial, the aggressive, while the small ones are gaining some reproductive success by sneaking in, while the large male is guarding a harem of females. That's very much population biology, very basic story, actually. The other pillar of this story is insulin. And we all, when we say insulin, we immediately think about blood sugar and diabetes and things like that. But no, this is a family of molecules that you can see here, like from Homo sapiens. This is the one that gained its popularity as related to diabetes and so on, but there are many more insulins. And in our laboratory, during a PhD study of Rivka Manol, here I could say a survival from Barry, and she discovered another insulin in crustaceans and found that this insulin is an androgenic hormone. Means that when it is there, the animal will develop into a male. Okay? And if you look at it from the beginning is the sperm and egg. Okay? There is a development throughout different stages till the establishment of a switch in which its on is with the insulin-like takes you to a male development, and when it's off, it's a female. So there is a gland that is producing this insulin, and when the insulin is there, we have a ZZ male. Okay? In the absence, and this is a switch, okay? In the absence of the insulin-like hormone, okay, then there is no IAG, and the development is into a WZ female. And you can see that it's not like in humans that we have the XY, here is the W and Z heritability. Okay, so from this, it is really a basic story on the development of, or the differentiation of males and females. We had in hand a tool in which we could decide, regardless on the genotype of a species or a specimen, we can decide if it's going to be a male or it's going to be a female. Okay? And we can do it in the laboratory. So the IAG switch is of basic interest in sexual differentiation, but it's also a tool. And we were using this tool for various issues in the laboratory. But outside the laboratory, if you look again into this romantic story of the population biology, the females are uniform, medium size, unlike the males that are all the range. And if you think about a farmer that grows, let's say, apples, he wants his apples to be as uniform as possible, so the processing and the culturing is administered easily. Okay? So there is a need for a product that is uniform, medium size. And now in the Far East, these are regarded as delicacy, and people are growing those. Okay? But when they grow them, you know, same age, same batch, they will get animals of 10 grams and 80 to 100 grams, which is a real problem in applications. Okay? So the question was, how could we grow uniform, medium-sized animal? And it came back to the laboratory, and this laboratory knows how to deal with the sexual switch, right? So we can decide who is going to be the male and who is going to be the female, and then we have to think how will the whole population, the entire population that a grower in Thailand is growing, will be only females. This was really applied, not romantic questions of social structure and not insulin. This is really something that in the industry, and indeed it was a big challenge, and it was a challenge that is larger than a laboratory can hold. First of all, it's very applied to our understanding. Secondly, it's extremely expensive. So the next thing to do was that some of the graduate students, here is Asaf, and here is Ohad. They just finished their PhD in the laboratory, and they said, well, we want to go out to the wild arena of industry. And we take this question of how to produce only females into a startup company. They call it Ozotic. It was established with Ben-Gurion University. And the issue was to solve this problem in a way that it will be industrialized. So for this we have to go back to biology, tiny biology. If we are crossing a male and a female, okay, so the male is, the female is donating the W and the Z sex chromosomes, while the male is donating only Z chromosomes. So the result will be males and females about 50%. So what should one do in order to produce only female population? And the result, as the students and in the laboratory thought, would be if we could create something that does not exist in nature, which is a super female, a WW female. And this sounds like science fiction, but if we have something like that, indeed, the female will donate its W chromosome, the male its Z chromosomes, and the entire population will be of all female, and the growers in Thailand will grow all females, uniform size, and kind of solving a technological problem and having their solution there. And to make a long story short, it took about 10 years to the company, and it survived, and it's still surviving. Even Asaf is still the CEO, and the company moved to do its experimentation in Thailand because they are growing it there. It's not, we know the biology, but they are. And here you can see the first harvest of prawns. First of all, look at the harvest of prawns. All are uniform size. You don't have the giants, you don't have the dwarfs, okay? And you see the distribution, and you see, and here is Asaf. You can recognize him. So the company took those principles, the biological principles, and was able to really implement it into the mode of activity in the industrial arena. Okay? So then we had to cope with all kind of, I would say, nonsense of the relationship between our university and a company. And then came several companies that were interested in all kind of applications there. And we were collaborating with them. So the major idea when you're talking university and companies is a classical tech transfer, right? That you have patent and you give it to a company and that's it. But here, that was our kids, like the students. And so we had to develop something like a continuous long-standing relationship without making the laboratory a R&D part of a company, okay? Which is a danger. So we had to see what's the financial exchange here. Like they give us research grants, They pay the university royalties. There is equity. There's research access so that our students could continue and study issues that are of less importance to the company or maybe more interesting for us. And I will show you in a moment some examples. And also, we were involved in the company, like in what kind of R&D should they do. They were coming to us for advice, to sit in the board of directors of the company. This is really deep involvement. Okay? Just to get the product. And then we could see what could be the collaboration between the company and the university. Let's say that here we were able to test the issue of do we really, with playing with the IG switch, produce all-female population, and what is the result? And here is Melody, who was doing a PhD in the laboratory, and she was invited by the company for 3 consecutive years to come to Thailand and to study the population structure. They're not interested in that. The population structure of the all-female. And here are some of her results that were really used for the future high-tech aquaculture. And then we granted a ticket to enter into something that is really tempting here, which is the CRISPR Israeli Genome Editing Consortium, which was extremely well funded, and we could continue the study with other companies like Avogen, like Colors, and see what we can do. And what did we gain out of that? What did we gain out of that? First of all, big genomic and transcriptomic data sets. Leslie. Big genomic and transcriptomic data sets that were developed in the laboratory, like an exclusive genome for this organism, which is totally a non-model organism, okay? And several transcriptomes, and then we developed a platform, and you can see, to inject the embryos with CRISPR-Cas9 and do the process of genome editing while the embryos are just developing in their early stages. So we gained powerful tools for molecular biology that we didn't have it before. Like the genome itself, at that time, now it's much easier, but the genome itself at that time was about $450,000, all subsidized by the companies and the consortium. Our laboratory would never do that. Just not possible. Okay? And then this leads me to the end of this talk, which is referring to basic questions that now, at this point, we are asking and answering. And this is Hanin Watat, who's a PhD student, and she is looking at markers of the early embryonic germ cells to understand where this all began. Very basic. Okay? And Hanin is taking a whole set of cells from the embryos, and with the facts you can see she is looking into the groups of cells. She's dividing them into groups according to size and granularity, and she's checking every group to see whether she has the markers of a germ cell to start study where this all begins. Okay? And here you see that population number 3, what do you call it, is the one that is obeying the rules or having the markers to show us these are the embryonic germ cells, and this is what she is doing for her PhD. Okay? Very basic. And then let's go back to Melody. She was looking at the IG switch that governs the male to female differentiation. Okay? But the question is, okay, this is a W and Z animal. ZZ is a male, WZ is a female. So what's the relationship between the high sexual determination of males and females and this differentiation process, okay, of the switch? What is the relationship between this and the W and Z sex chromosomes? Okay? What are the elements there that are governing the transcriptomic events upstream the IG switch? This is her question for her PhD. This is after 3 years going back and forth to Thailand and to see what's really going on when you are doing the manipulations. And now back to very basic. And her last, really last moment article was in Biology of Reproduction, okay? Dealing with this relationship. So, Melody, and I rest here and leave it with the question here. I am very much aware of the concerns, and I'm concerned when it is becoming too dominant, the issue of applied. But when in the laboratory I can navigate, I'm doing basic. Or is the applied applied? Is the basic basic? Question. Yes.
I'd like to make a more general comment following your presentation about the basic, the relationship between basic and applied research. I'd like to draw the attention of the audience to a book which I published last year. The title of the book is The Revolution in Science in America in the 20th Century. By the way, my name is Jacques and I'm a visiting professor in this department. And the point that I want to make is that at the beginning of the 20th century, the federal government in the US did not support basic research because they believed it was a waste of the taxpayers' money. It was only after things which are documented here that after the Second World War, in 1950, the National Science Foundation was founded and they started to support basic research. And that led to the huge rise in world domination of America in science. So there's a clear correlation that support of basic research does provide the society as a whole with a huge increase in technology and science that aids, that helps everybody. And I think that general point needs to be made.
Totally agree.
And I think the point I have here is that it's documented in this book.
Yes, I totally agree, and I think that there's
Can you speak
not
up?
enough support
Yes,
for basic science.
thank you.
Yeah. Yeah, thank you very much. First, I think the development in Europe is different from the development in the United States.
Absolutely.
But we will talk about that later on. But
Absolutely.
Amir, I have a question. The collaborative research, were you able to publish them freely, the results?
Yes, some and some. Okay. If you look at the list of publication of the students, and we were exposing the students to things that were not of major interest to the industry, but of major interest to us as basic scientists, you could see that there are a lot of publications that are actually a result of this activity with the industry, on one hand. On the other hand, there are some things that they will not let us publish unless there is a patent writing or something like that, which is a headache. But at that point, what we did is we tried to help the company write the patent, and then you are free, because the patent is published, and then you are free. But this is really it's a challenge. It's a challenge. Thank you so much.
Thank you, Amir. Invite our next